Hey, second period, Mr. Cruze here with the 8.1 lesson for you today. I just need you to follow along with the notes here as we go through them. If at any time you get stuck or you need to slow down or anything like that, just ask whoever is taking my place today just to kind of pause the video and wait for you to catch up, okay? But please take notes, please pay attention as if I were there. I'm just across the hall talking to a different class about next year's higher level math classes. So obviously if you have questions, you can stop by during power hour and all that good stuff. So let's begin. We're going to talk chapter 8. We get into right triangle stuff. So we're going to be doing a lot with right triangles. A lot. We'll be solving them eventually at some point, but for now we're going to talk about geometric mean and the altitudes of right triangles. You guys probably are familiar with the arithmetic mean, where if you have 5 numbers, you add them together and you divide by 5 to find it. Well, the geometric mean is a similar concept. It's not as commonly used as the arithmetic mean. But here's what it is. We would say x is the geometric mean of two numbers a and b if the following is true. If a over x equals x over b. Okay. You might recall I called these middle numbers before in chapter 7. I called those the means, right? Well, now it makes a little bit more sense. If those two are the same number, then they are the geometric mean of a and b, okay? And you notice if you cross multiply here, you get ab equals x squared, right? So it turns out x is the geometric mean if I were to take the square root of a times b. So this is the important part. To find the geometric mean of two numbers, multiply the two numbers together, and then take the square root. Again, please be careful, and we're going to be using this a lot this chapter. Make sure you're actually taking the square root and not squaring a number. We do not want to square a number, we just want to square root it, all right? We are going to break any radicals up. We're not going to worry about decimals. Any radicals we come across, we're going to simplify just like you did back in Algebra 2. Essentially, factor tree, right? And break it down into its prime factors. You're looking for pairs of numbers, because this is a square root. So let's try. Find the geometric mean of each pair of numbers. We might use this handy-dandy list of perfect squares to help us out. So find the geometric mean of each pair of numbers 4 and 9. So literally we're going to multiply these together. 4 times 9 is 36, and then we are going to take the square root of 36. Hopefully most of you realize that's 6 times 6, so that's my pair. So this is 6. So the geometric mean of 4 and 9 is 6. Now please notice that is different from the arithmetic mean. If I were to add 4 and 9, I get 13. Divided by 2 is 6.5. So the geometric mean and the arithmetic mean are not the same thing. Not to say that they couldn't be in a situation, but usually they are not the same. All right, how about 10 and 14? So I take 10 times 14, I get 140. And now we're going to square root 140. Now, this is a little bit of a problem because 140 is not on this list. It's not one of our perfect squares. So we need to break it down. So let's see, 140. Obviously, you could just break it down like you just did, 10 and 14. 10 is 2 times 5. Those are both prime numbers, so I'm done there. 14 is 2 times 7. Those are both prime, so I'm done there. And notice we have a pair of 2's. So the 2's are going to come out as a single 2. They come out as a whole 2. And then the 5 and the 7 have nobody left behind, so they're just going to get multiplied back together. So this will actually be 2 radical 35. That is the arithmetic mean of 10 and 14. How about 4 and 12? So 4 times 12 is 48. Square root of 48. Okay, so think about what breaks down to 48, or what multiplies to 48. And again, you might have lots of different options here. Most of you might go like 2 and 24. I'm going to go 6 and 8, just because. 6 is 2 times 3, of course. 8 is 2 times 4. So already I've got a pair of 2's. And then the 4 itself is a pair of 2's, right? So we actually have one pair of 2's and a second pair of 2's that are going to come out. Those multiply together. So that would be 2 times 2, that's 4. And then what's left behind is the 3 inside. So it's actually 4 square root of 3. Okay, again, that's a 2, and this is a 2, and we're going to multiply them together. All right, that's how we got that 4 out front. Just like we got the 35 in example 2, it was just left behind. So anything extra that's pulled outside is going to be multiplied together. Anything that stays inside is going to be multiplied together. All right, how about 3 and 39? That will be 117. So if we take the square root of that, square root of 117, you might think, well, it doesn't break down, but sure it does. 3 times 39, obviously. That's how we got it. 39, 3's done, but 39 actually is 3 times 13, right? And notice, look at that. We got a pair of 3's. The 13 is all by itself, though. It's all alone, so it stays behind inside the radical. So it's 3 radical 13, okay? Again, this part should be a review of Algebra 2. If you need help breaking down radicals, obviously come in during Power Hour, and we can work on that. We're going to be doing a lot of breaking down radicals this chapter, so it's important you understand it. But as far as my class is concerned, geometric mean, just make sure you know multiply, and then take the square root. All right, go ahead and flip it over to the back. This is where things are going to get a little hairy, so please make sure you are paying attention here. All right, imagine we have a right triangle, okay? And you notice I have oriented this picture so that the right triangle is pointing straight up. You don't have to do this, but I think it'll be helpful for when we go to do these problems, okay? So you notice what we did is we took this right triangle and we drew in its height. I called it h. We drew in its height, notice it's perpendicular, to the hypotenuse, okay? So if you notice from the very beginning, maybe I can get rid of this for a second. If you notice, before I even did this, right, angle B is the right angle, so that makes side B over here, segment AC, that makes that the hypotenuse, all right? And then what we did is we drew in the altitude, the height, to that hypotenuse. You notice it splits it into 3 triangles. There's this triangle, which is a right triangle, this is triangle ABD. There's the slightly bigger triangle, triangle BDC, and then there's the entire big triangle, triangle ABC, okay? It turns out they're all similar by angle. Obviously, they all share a right angle. You will notice that the little triangle and the entire triangle both share angle A, okay? Which means the little triangle and the big triangle have to be similar by angle similarity. Likewise, the medium-sized triangle, triangle BDC, and the entire triangle share angle C, right? Which means they are similar by angle. So if you think about this logically, if the small triangle is similar to the big triangle, and the big triangle is similar to the medium triangle, they are all 3 similar to each other by transitive property, right? So it turns out the following is true. Triangle ABD is similar to triangle BCD, is similar to triangle ACB. These are all similar triangles. And as a result, we could set up proportions, right? Because if they're similar, all their sides are in the same ratio. So one of the proportions we could set up is we could put B over C, which you'll notice is the hypotenuse in the big triangle over the smallest side. And we would set that equal to C, which is the hypotenuse of the little triangle, over F, which is its little side. So basically we're setting hypotenuse over little side equals hypotenuse over little side. And then we can do the same thing with B over A, hypotenuse over long side equals, and then in the medium triangle, hypotenuse over long side. And we can do the same thing between the little and the big triangle. F over H, little side over long side, equals H over G, little side over long side. I wouldn't worry so much about setting up these proportions, but they do result in some helpful equations. For example, if you cross multiply all of these, you get the following. C squared equals F times B. So I call this the hot dog. Okay, so what this tells me is C squared, so we're going to square C, equals F times B. Those go together. That's my first hot dog. A squared equals G times B. That's this one. A squared equals G times B. Okay, notice the A and the C are the squared ones, and the G times the B, those get multiplied together. The F times the B, those get multiplied together. There's my hot dog and my hot dog. And then we have Hershey Kiss right here in the middle. Okay, and this one is H squared equals F times G. So there's going to be 3 different relationships here. We've got A squared equals G times B, we've got C squared equals F times B, and we've got H squared equals G times F. Those are going to be our 3 things. I call them hot dog, Hershey Kiss, because that's essentially what it is. Also notice just one more thing. Notice that B down here is really F plus G. If you add those together, you can get all of B. All right, let's see if we can actually try some. Again, if the picture is not oriented in this way, you can rotate your paper to make it work. All right, so let's solve for the variables in the following diagram. Simplify radicals when necessary. So this very first one, I noticed that I have the y and the 9 here, and I've got the x and the 1 here. I could do this whole side. Notice this whole side is basically my b up here, right? And then we can do hot dog. The question is just which one is squared, right? Well, you'll notice if you orient it, these three up here are the ones that get squared. All right. So if obviously this picture is upside down, so that means y is going to be the squared one. So y squared ends up equaling 9 times 10, which means y squared is 90. And you'll notice y is the square root of 90. Essentially, y is the geometric mean of 9 and 10, right? So square root of 90, let's see, that breaks down into 9 times 10. 9 is 3 times 3. 10 is 2 and 5. So the only pair there is a 3. So this is y equals 3 radical 10. That's y. All right, now x, same kind of thing. Hot dog, right? X squared equals 1 times 10. X squared equals 10, so x equals radical 10. And by the way, I don't have to do that again because I know that 10 only breaks down to 2 and 5, and there's no pairs there. So there you are. X is radical 10, and y is 3 radical 10. It's that simple. Hot dog, Hershey Kiss. You just got to figure out which one is squared. All right? So if you take a look at the next one, number 6 here, you will notice x is in the middle this time. It's our h. You will notice they give us the whole side. We are oriented correctly here, but this part is 40. I do need to subtract. 60 minus 40 is 20. And then we can do hot dog. So y squared equals 60 times 20, right? Which is 1,200. So y is going to equal the square root of 1,200. We need to break that down. I might just go 60 and 20. Now I'm going to give you a little shortcut here. 60 itself is 3 times 20. Do you notice how I already have a pair of 20s? I don't even need to break those down anymore. I can just go ahead and pull that out. 20 and then the square root of 3 left behind, okay? Again, you can break those down. You'll see 4 and 4. You'll notice another pair and a pair of 5s and things like that. But it should come out to be 20 square root of 3. All right, now as far as x is concerned, x is in the middle this time, which means this is a Hershey Kiss problem, all right? So, but again, the x is going to be the squared one. This will be 40 times 20 this time, which is 800. And then, so x is the square root of 800. And again, I'm going to break 800 down like we did before. I'm just going to do 40 and 20 because that's what it started out as. 40 is 2 times 20. And again, notice we've got a pair of 20s. So I'm actually done. So the square root of 800 is actually 20 radical 2. And that's x. All right. All right, if you want, you can pause if whoever's playing this YouTube video wants to pause the video and let everybody try this next one. They have to find all three, x, y, and z, and then I'll do it real quick and they can check their answers. So pause the video now if you'd like. All right, again, this one, notice it's oriented pretty well. We've got the 10 there. So I'm going to do hot dog, Hershey Kiss. So the first one, hot dog here, will be x squared equals 4 times 10, which means x equals the square root of 40. 40 is 4 times 10. 4 is 2 and 2. We've already said 10 won't break down. So x is 2 radical 10. As far as y is concerned, that's a Hershey Kiss. So we get y squared equals 4 times 6. So y ends up being the square root of 24. Again, you can break that down, 4 and 6. 4 is 2 and 2. 6 is 2 and 3. I've got one pair of 2s. So we get 2 radical 6. And as far as z is concerned, we've got another hot dog over here. So that'll be z squared equals 6 times 10. So z equals the square root of 60. 60 breaks down into obviously 6 times 10 again. 6 is 2 times 3. 10 is 2 times 5. And notice between the two of them, we do have a pair of 2s. So this will actually be 2 radical 15. When it's all said and done. So there you have it. Just make sure you know hot dog, Hershey Kiss, and you've got it.